question 11. Hydrated aluminium ions undergo the following reaction. There you've got your equation, and then which statement about this reaction is correct? Now, this is a reversible reaction, so this is likely to be exploring the ideas of equilibriums, and also potentially here we can see this is about acids and bases, or conjugate acid-base pairs. Okay, statement A, water and the hydrated aluminium ions are a conjugate acid-base pair. So let's look at this equation. Let's find out what the conjugate acid-base pairs are. Okay, now first let's remind ourselves of what a Bronsted-Lowry acid is. Okay, that's really important that we know this definition. Right, so I've just typed in a definition here. So an acid is a proton donor, okay, and a base is a proton acceptor. This is the definition that we will use that works for our course, okay? Now, you may, in previous years, you might have thought of, for example, bases as being hydroxide ions, and that's not quite the case, okay? We have to move on from that definition. So a base will accept hydrogen ions and an acid will donate them. Right, so let's look at this equation. So this species here, let's see what it's changed. It's changed from this to this, okay? And as you can see, the charge there has gone down by 1, okay? In other words, it has donated a hydrogen or donated a proton. So this here is the acid, okay? And this species here, the water, has accepted a proton, or has accepted a hydrogen ion, okay? And that's why it's gone from water to H3O+. So this is our base. Now, as this is a reversible reaction, if you look at it the other way, okay, then if you're looking at the reaction going this way, going backwards basically, then on the other side, this would be your acid and this would be your base. Because if you're looking at the reverse reaction, it is this species, the H3O+, that is donating the proton, okay? So it's losing that proton and becoming water. And the same goes for the base becoming an acid. It's accepting a proton. So for the acid going in, it's going to be paired up with the base coming out. So for statement A, it says H2O and this species here, which is the one coming out, are a conjugate acid-base pair. Well, that's incorrect, okay? The acid-base pair would be this and this, okay? And this and this. So the H2O and the aluminium ions here, the 2+ ones in the product, they are not a conjugate base pair. So this is incorrect, okay? Second point, H2O is acting as an acid as it's donating H+ ions. No, that's incorrect. H2O is acting as the base because it's the thing that is accepting the proton. Okay, so that is incorrect. Right. C, if OH- ions are added, the equilibrium will move to the right. Now, this is the correct answer. C is the correct answer here, and I'll quickly explain why. Right, so I've written out the equation here in a slightly different way. I've got rid of the water here, just because it's kind of confusing matters, and I've got rid of the H3O+ here, and I've just put the hydrogen ions there. And it's just because I want to make it easier to understand what is going on. So if you add hydroxide ions here to this reaction that's going on, or to this reaction vessels, those hydroxide ions, okay, if I add them to this reaction vessels, they are going to combine with this H+ ion, okay, producing water. So effectively what's happening there is you're taking away one of these products, okay, and in taking one of these products, according to Le Chatelier's principle, the equilibrium is going to try to oppose that. So it means you are going to shift your equilibrium to producing more of what's on this side, okay? So if you added OH- ions, effectively they'd latch onto the hydrogen here, the H+ here. they'd therefore take that away from the product side. In other words, it'd be like removing a product. Therefore, the equilibrium is going to try to counteract that, and it will shift to the right-hand side. It's a very tricky question, to be honest, but that's the reasoning behind it. Okay, final point here, point D. This is obviously incorrect now that we know the answer is C. Kc will not change. In other words, this is the equilibrium constant. This is the value for the equilibrium constant. Now, the only thing that is going to change the equilibrium constant is changes in temperature. It's probably best just to learn that. So Kc is only going to change as a result of temperature changes. So that's why D would be wrong.